This is section 4.4, and first we're looking at the multiples of a number. So when we multiply a number by the whole numbers 1, 2, 3, and so forth, we form multiples of that number. And the least common multiple, LCM, of two given numbers is the smallest whole number that is a multiple of each given number. So in our first example, we're going to find the least common multiple of the given numbers by listing several multiples of each. So we'll look at the multiples of 15. 15 times 1 is 15, 15 times 2 is 30, 15 times 3 is 45, then 60. So we're counting by 15s. And next, the multiples of 12. 12 times 1, 12 times 2, and so forth. And what we see is that we have a common multiple of 60. Find the least common multiple of 10, 15, and 8. So we'll write several multiples of 10, 10, 20, 30, 40, 50, etc. Multiples of 15, and multiples of 8. And we had to go pretty far to get a common multiple, but our least common multiple is 120. The next skill here is to write equivalent fractions. So what we can do with a fraction without changing its value is multiply by 1. So if I take the fraction 2/9 and I multiply by 1, I'll have a fraction equivalent to 2/9. Well, if my denominator is 9, but I want it to be 36, if I multiply 9 times 4, I get 36. But I also have to multiply 2 times 4 so that I'm multiplying the entire fraction by 1 so as not to change its value. When we multiply fractions, we go across the numerators and denominators, and so our equivalent fraction will be 8/36. Here we have 11/8. Again, we can only multiply this fraction by 1 to get our equivalent fraction with a denominator of 56. So 56 divided by 8 shows me that I'm missing this factor of 7, and therefore I have to multiply the numerator by 7 as well. 7 times 11 is 77. So what I'm actually doing is taking this fraction out of lowest terms and giving it a denominator of 56. I'm going to do the same thing, but I want a variable in the denominator now. So I have 2/3, and I want my new denominator to be 9x. And so I have to see what can I multiply 3 by to give me 9x. So if I multiply by 3x, then these denominators match. And so if I multiply by 3x in the denominator, I have to multiply by 3x in the numerator. Multiplying across, I get 6x over 9x. So these are equivalent fractions. If I reduce this fraction, 6x over 9x, that brings me back to 2/3. So we're intentionally taking a fraction out of lowest terms to get an equivalent fraction with the indicated denominator. So here I have 4 over y, but I want my denominator to be y squared. So I recognize to go from y to y squared, I need another factor of y. So I need to multiply by y over y. Again, we can only multiply by some form of 1 without changing its value. Y times 4 is going to be 4y. The least common denominator, LCD, of two fractions is the least common multiple of the denominators of these fractions. So if I want to compare 3/5 and 4/7, I'm going to find common denominators, and the least common denominator will be the least common multiple of the denominators. So I will start by finding the multiples of 5 and then the multiples of 7. So I have 5, 10, 15, 20, 25, 30, 35. 7 times 1 is 7, 14, 21, 28, 35. So I see that my common denominator is going to be 35. So now I'm going to write equivalent fractions with denominators of 35. So I'm going to take the first fraction here, 3/5, and find an equivalent fraction with denominator 35. And then I'm going to take 4/7 and write this as an equivalent fraction with denominator 35. So for my first fraction, I'm going to multiply by 7/7, giving me 21/35. For my second fraction, I'll multiply by 5/5, giving me 20/35. And then I see that 21/35 is greater than 20/35. Therefore, 3/5 is greater than 4/7. And you have some practice problems to try.